Is the Earth flat? It may sound like a question from centuries ago, yet today millions of people around the world genuinely believe the Earth is not a globe, but flat. Not as satire, not as symbolism, but as physical reality. They argue that we have been misled, that what we see is not what we are told, and that institutions cannot be trusted. But could millions of people be wrong? Or is there something deeper behind this belief? Tonight, we examine the evidence. For centuries, the shape of the Earth was considered settled science. Ancient Greek scholars measured its circumference with surprising accuracy. Explorers navigated vast oceans. Modern satellites orbit the planet every day. And yet, in the digital age, the flat Earth movement has resurfaced. Why? Because doubt spreads faster than certainty. And when trust in institutions weakens, alternative explanations gain power. Flat Earth supporters often raise questions that sound simple. Why does the horizon appear flat? Why don't we feel the Earth spinning? Why does water always find its level? Can images from space truly be trusted? At first glance, these questions appeal to common sense, but science often shows that common sense is limited by perception. So what happens when we measure instead of assume? When ships sail away across the ocean, they do not simply shrink into the distance. They disappear hull first, then mast last. If the Earth were flat, the entire ship would only become smaller, not vanish from the bottom up. During a lunar eclipse, Earth casts a perfectly round shadow on the moon. Only a sphere consistently casts a circular shadow from every angle. Time zones create daylight in one part of the world while another remains in darkness. On a flat surface, this pattern would not occur naturally. Then there are direct measurements. Over long distances, high-powered lasers and precision instruments have been used to test curvature. Interestingly, some experiments conducted by flat Earth groups themselves measured results consistent with curvature, even when that was not the expected outcome. So if measurable evidence exists, why does the belief persist? Because this debate is not only about geometry. It is about trust. It is about identity. It is about the human desire to question authority and uncover hidden truths. In a world overloaded with information, certainty feels fragile, and alternative narratives offer clarity. But science is not built on belief. It is built on repeatable observation. The question, is the Earth flat, may seem simple, but perhaps the deeper question is this: how do we decide what is true? Through perception, through authority, or through careful measurement? Curiosity is powerful, and questioning is essential. But evidence requires testing. So, is the Earth flat? What do you think?